work with syslog and for the early detection of threats.
Hola, mi nombre es Jenny
Hello, I'm Jenny Zambrano, and I come from Ecuador, and I'm going to present my research work of the monitoring work that is called centralized monitoring of security in events in ISP networks with syslog for detection of threats.
To carry out this research work, we started with a problem. We had an issue that the limitations we currently have in the network devices were the problem. So when generating the records in these devices, these are recorded locally. In other words, they tend to overwrite these in the devices. I have two relevant facts as well. There are 2.8 million IPs, public IPs, that are attacked every day. And then there are more than 4,000 ISPs attacked in massive campaigns of brute force attacks. These are facts from hackers vendors. And because we have this problem, we set the objective, which is to design, implement, and validate a centralized monitoring model for security events in ISP networks, implementing syslog registers and analyzing this in an open source SIEM platform with the aim of detecting threats at an early stage and improving the response capacity of the technical team. So we defined the following methodology. We started with a network diagnosis. With this aim, we identified the critical devices and the registering capacity. Here there was something that was quite interesting, because at the company where I work in Ecuador, in AlphaNet, we have multi-vendors. We have multiple vendors. This allowed us to have an interesting challenge. We then implemented this SIEM platform. This was something that was quite interesting. We started by identifying an open source tool in order to share this with all the operators in the region. We researched a tool, then we deployed and did the initial configuration of the tool. We prepared the OS. Once we had the operation system, we prepared the services and started carrying out the initial tests. After that, we did the syslog configuration, as I mentioned, identifying these devices because these are from multiple vendors. This is quite an interesting challenge. We saw that there were various brands. So in order to do the syslog configuration, this also varied depending on the device which you were configuring. We therefore had to verify how this configuration was carried out, in addition to identifying the relevant information for the organization. Following that, we developed the decoders and rules. When we had configured all the syslogs, we already had the platform, but we couldn't yet identify things. We couldn't visualize this in the platform because we didn't have the dashboard. That is why we enabled an archives issue. This allows us to receive the logs and of course depending on each of the vendors. So following that, we were able to do the configuration of the automatic alerts. We first configured the decoders, we then configured the alerts. The alerts should be configured based on the needs of the organization. Once you have the alerts configured, you have to identify the indicators of compromise. Once you have these, you see which is the alert you can use to identify an attack vector, an access vector. You identify the rule, you do your parameters for the timing, as well as the IP from which the attack could be done. And after that, you define a level to know, to receive the notifications ultimately. So we did then the automatic alert configuration. This is done with an integration with another platform. Well, in this case, we used a platform that has channels. You do the integration with a SIEM. Once that is integrated, you have the channel. Once you have the channel, you integrate the entire equipment. And once everything is done in the SIEM, you define the parameters for the alerts that you will be receiving. This slide shows a topology design. In the organization, we have core, border, and access devices. All these devices send the logs to the SIEM. This is centralized, and an important point here that should be mentioned is that in the organization, we are top 5 in Ecuador. So we have more than 200 devices that we integrated in this project. Once you have this in the SIEM, if the alert exceeds a given threshold, you will be notified to your mobile phone or through the web. And on the right, you can read the result that we have now. So that shows the name of the equipment, and for reasons of confidentiality, I didn't include the entire label. And you can also see the date where this was attempted. We should also highlight that the clock has to be synchronized with the current clock. You also see the IP over here. Well, let me give you an anecdote here. Regarding this specific case, this was done with a networking boss. They were configuring the equipment before sending it to production. Once we had all everything prepared, and he said, well, everything is set. It's all set so you can start operations, because as you're aware, you do have to establish certain blocks, and in theory, you have to block port 22. So when it went into production, we started receiving a lot of alerts. I said, well, what is happening there? You're not blocking. Yes, it is blocking. So we had a joint meeting, and when we were revising this was a configuration error. The OSL was there, but it wasn't sending the blocks through the proper interface. In other words, the port was exposed. And this could happen to others as well, but this is just an anecdote in the context of this example. So we have here a level 12 alert, and of course this is done in real time. I will now refer to the relevance of this work. This is a critical challenge because it approaches early threat detection in the infrastructure, in the network infrastructure at a large scale. We have quite a big infrastructure in the country. We are distributed throughout the country, throughout Ecuador. This is another important point is integration to have a centralized monitoring model with syslog and SIEM. And SIEM is open code, which is interesting, so everyone can use this. And we only have to consider the hardware. This was also validated. The centralization was validated and standardized. And we had considered multiple vendors, so for each vendor we had to configure the rules and the decoders and so on. Another relevant point is the integration of detection. We use reference frameworks such as MITRE ATT&CK. This is a practical methodology. This is a methodology that I recommend to use in our environments and in our ISPs. This can be replicated in all the ISPs of the region. So after this you have any questions, please feel free to contact me and I will explain how we managed to integrate this in the organization. Another relevant point are the improvements, visibility and early response capacity. So the experts on information security, what we're most interested in is having the visualization of the network and everything that is happening to our infrastructure. This allowed us to have this visibility, and we continue to analyze what is happening in the network. In addition to that, this is a technical proposal. It's a technical, open, and scalable proposal. You can install it in your organization and then scale it up. This is not limited. You can integrate this and monitor the servers. You can do cloud monitoring, etc. Regarding the conclusions of this research project, this is a centralized monitoring model that was designed, implemented, and validated successfully. In terms of achievements, we managed to integrate multi-vendor devices, decoders with MITRE ATT&CKs, the T11110, and automated real-time alerts that allows to protect ourselves if we find any anomalies. When AlphaNet reinforced the security position with a centralized vision and greater response speed. This allows you to connect to proprietary brands, and this allows you to benefit more. What are the challenges we had in this project? There is heterogeneity in the syslog configuration. Between vendors, for each of the vendors, you have to do the configuration. A further challenge involved ongoing adjustment of the rules in order to reduce the amount of false positives. As I said, you have to start analyzing which are the compromise indicators that might be affecting your organization. A further important point is capacity building of the personnel on open source SIEM. You have to be curious, you have to research the tool, you have to read all the documentation, and following that you can proceed to the implementation. Another challenge was managing the growing volume of records, because we are top 5 in Ecuador. We have a large volume of syslog. What are the opportunities we found through this project? This can be, you can incorporate machine learning to anticipate complex patterns. So this is one of those future steps we are considering in the organization in order to improve this tool as such. We also have to expand monitoring to include services and critical applications. As I said, this is a generous tool because it allows us to integrate our services. It can also be integrated to the cloud. Furthermore, we can be integrated with SOAR platforms in order to have automated response. Any questions? Any questions? So thank you very much, Jenny.